This video is on lesson 37-2, pyramids and cylinders. We are continuing to look at the dimensions. As you change the dimensions of the shapes, how does that affect the perimeter, the area, surface area, and volume? In the last section, we looked at only cubes and only spheres, because those only have one measurement. This, however, have more than one measurement, but you're going to find that the relationship is the exact same. So in this picture right here, in this problem, they want to know which ones are similar. We can tell which ones are similar by using the corresponding parts. So for this one, we would take this front edge, which is 20, and that corresponds with 17.5. Check the ratio, see if it's equal to the height ratio. If this is equal, then they're similar. If it's not, then they're not. So you cross multiply right here and you get 200. You multiply 17.5 times 12, and you get 210. So these two right here are not similar. You come over here and you'll try this one. You do 17.5 over 14. See if that's equal to 10 over 8. And then cross multiply, see if they're equal. 17.5 times 8 is equal to 140, and 14 times 10 is equal to 140. So pyramid 2 is similar to pyramid 3. Now we need to check 1 and 3. We've checked 2 against each one of them. Now we need to check 1 and 3. And we do it the same way. 20 over 14, is that equal to 12 over 8? Cross multiply. 14 times 12 gives me 168, and 20 times 8 gives me 160. So, no, the only ones that are similar are pyramid 2 and pyramid 3. So, we're right. Pyramids 2 and 3 are similar. The dimensions have a scale factor of 5 to 4. So, the way you find 5 to 4 is to take either one of these and reduce it, and 10 over 8 reduces down to 5 over 4. Of course, you could write it as a decimal also, and I think that's 1.25. Let's see. He built a square pyramid. The base edge is 10 centimeters and the height is 12 centimeters. He knows that he needs the height of the second pyramid to be 24 centimeters. Determine the scale factor of the small pyramid to that of the larger. So we compare the base edges. Built a square pyramid. The base edge is 10 and the height, so square, base edge is 10 and the height is 12. And then he knows the height of the second pyramid is 24. So there's where they put 12 over 24, and that reduces to 1/2. Determine the scale factor of small pyramid to the large pyramid. Determine the length of the base edge. So you take 1/2. 1/2. This is from the small pyramid. So 10 is from the small pyramid. Then what's going to go down here? You cross multiply and you get 20. Okay. This next one, I am using this because really and truly what we want to get to is the relationship. If you haven't if you want practice on how to find the perimeter of the base, the area of the base, the lateral area, surface area, volume, then please pause this video and go back and do these by hand. I don't need to do that. I can do all of this. I just want to look at the chart and see if there's a relationship. So notice the units: inches, 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 and the scale factor matches. So every time, if our two pyramids are similar, then any scale factor of any two measurements that just have inches should have the same scale factor. So the height compared to the base edge, the height of one compared to the height of the other one, the base edge of one compared to the base edge of the other one, the slant height of one compared to the slant height of the other one, the perimeter of the base. The perimeter is still just in inches. So the perimeter of the base of one compared to the base of the other will reduce down to 1/2. So these corresponding parts, any parts that have a measurement in inches or centimeters or a singular unit, should have the same scale factor. Now what do we have? All of a sudden now we have inches squared, inches squared, inches squared, inches squared. Every measurement that has inches squared now has 1/4. Where did the 1/4 come from? You simply square that scale factor. Okay, so 1/2 squared gives you 1/4. And look at this one. This is inches cubed. When your volume or when your units is cubed, they got 1/8. Where did the 1/8 come from? 1/2 cubed. So there's still the same pattern, the pattern that we learned back when we did cubes and spheres. So 1/2 right here is the scale factor anytime you compare corresponding parts. That means that 1/2 squared will be the scale factor for anything with a square inch, and 1/2 cubed will be the scale factor for anything with the cubic measurement. Okay, he finds out that these are not proportional because you compare 4/6, and then you compare 3/2, and 4 on top, 4/6. You reduce this by 2, and you reduce that by 2, and you get 2/3 is equal to 3/2. So that's not right. So these are not going to be similar. And also notice that the scale factor, if you compare radius to radius, circumference to circumference, notice they didn't do height to height because that would have given them upside down. But then they went to square centimeters and it's still the same. Cubic centimeters and it's still the same. So just because you see the same scale factor all the way across different units of measurement, that's not good. You went from centimeters to square centimeters to cubic centimeters. They should not be the same. So be careful and don't fall for that. Okay. Let me jump over here to the student edition real quick. So we did that. Okay. So now on this one, we want to say, okay, what is the, let's say, formula, if there is such a thing. So here they say, here's a scale factor. The scale factor is A to B, 2 to 3, 1 to 2, 5 to 4, whatever the two numbers are. If that's the scale factor, by finding corresponding measurements, that's the key word right there, corresponding measurements. Remember, edges or radii, those are singular measurements. This is going to be just units. Okay, it's not going to be units squared, it's not going to be units cubed, it's just whatever units, inches, feet, centimeters, whatever. We go to perimeters, it's still just in whatever units. So since this is units just like this one will also have a scale factor of A to B. All right, now this one right here, ratio of areas. We know that areas is always whatever your unit is, it's always squared. So feet squared, inches squared, centimeters squared, yards squared, miles squared. So whatever an area is, it is, your units are squared. If your units are squared, so should your scale factor be squared. I don't know if y'all can see that flashing in and out, but that is crazy. All right, and then the last one for the ratio of the volumes. What are your units for volumes? It's units cubed. So since your units are cubed, then your ratio is going to be cubed. And by the way, this is A squared over B squared. I mean, you don't have to leave the 2 on the outside. So it's going to be A cubed over B cubed because you're going to take your scale factor, that came from your corresponding parts, and you're going to cube it. A cubed over B cubed. So this is the answer. Write your conjecture for the ratios of corresponding perimeters. That was part A right here. So this is part A to B. Write conjecture about the any pair areas. There's the key word. So that's A squared to B squared. Okay. And then volumes. There's the key word right there, volumes. And we know the units for volumes are cubed. A cubed, B cubed. All right. Draw and label two solids whose corresponding dimensions do not have the same scale factor. Based on the conjectures, verify that the two figures are not similar to one another. So this is just saying, show me that it doesn't work if they're different. So two solids. Let's do a rectangular prism, just because it's super easy to draw, and another rectangular prism. Like I'm drawing with my left hand. I'm not. Okay, it says make them so that their parts do not correspond. So let's make this 1, 2, 3, and let's make this 2, 2, 4. Now I know those are not going to be have the same scale factor, because this one right here doubled, this one stayed the same, and this one went up 1/3 by 1/3. So these are definitely not similar. So if we now find it says, based on the conjecture you made, verify the two figures are not similar to one another. So if we found the volume of this one and the volume of this one, they are not going to have this relationship. That seems like a complete and total waste of time. I'd much rather spend my time doing something where I know what the relationship is, not proving that it's not. Okay. Let's see. Okay, I'm still good on time. A tetrahedron has 4 faces, each of which are an equilateral triangle. So I've got 4 triangles here. The diagram below shows 2 tetrahedrons. Suppose the tetrahedron on the left has 6-inch edges, and the tetrahedron on the right has 8. What is the ratio of the surface area of the smaller tetrahedron to the larger? So I'm going to write 6 to 8 and then reduce it. And 2 will go into both of those. So that's 3/4. So 3/4, this is small to big. So 3/4, that's the ratio. That's the scale factor. That's my A to B. Okay, so just like we wrote in the formula a while ago, A over B is equal to 3/4. Now, I would probably argue that it should be 4/3, because I know I'm starting with this one and I'm getting bigger, and so I want a number that's going to enlarge it, but we can write our proportions so that it'll work anyway. So what is the ratio of the volume? Volume is the key word right there. Oh, this said surface area, so I'm not finished. The scale factor is A to B, so for surface area, we have to do A squared over B squared. So that would be 9/16, because they ask for area, so we square it. This one's asking for volume, so we take the 3/4 and we cube it. So that would be 27, I believe, over 64. So if I knew the volume of this one, I could find the volume of this one without actually having to use a volume formula. And I don't know what the volume formula for a tetrahedron is. So I'd have to do it that way. 2 similar cones have volumes this and this. Determine the scale factor. So you write a ratio of 125 pi over 64 pi and reduce it down as low as you can. 125 divided by 64. It doesn't reduce. I can reduce the pi's out, but that leaves me 125 over 64. But this is for cubic inches right here. So to find the scale factor, I have to take the cube root of both sides, because this is a cubed over b cubed. And so I need to find a over b, so I have to take the cube root of both sides. So the cube root of 125, I bet, is going to be 5. So the cube root of 125 is 5. And the cube root of 64, I believe, is 4. I'm right. So the scale factor, A over B, is 5 over 4. If the total area of the larger cone is 75 pi inches cubed, calculate the total area. So I've got 75 pi, and this is the larger one. So my smaller one is going to be my x. Okay, so I'm going to use not 5 over 4. 5 over 4 is 4 inches. Inches squared is going to be 25 over 16. So that's going to be the scale factor that I'm going to use. So 25 over 16. Now I cross multiply and divide. So 75 times 16 divided by 25 leaves me 48 pi. Now I did one thing that I was careful of, and I wanted to make sure that you caught that I did this. They said this is the larger one. So the larger one is on top, the small one is on bottom. So when I wrote this ratio, I made sure that my big number was on top and my small number was on bottom. If I had written it the other way around, x goes on top and 75 pi goes on bottom, then I simply would have written the bigger number on bottom and the smaller number on top. And then when I cross multiply and divide, I would have got my same answer. Okay, so you just have to be careful, because you have to pay attention to what they've given you, what what the relationship is to the scale factor, and how do I get the scale factor, and so forth. So it looks like that is the end of my examples. So you give this a try, and my last video for this unit will be going over these answers.